For this series in Spacecraft Guide, we are going to focus on the Space Shuttle. We're going to concentrate on the flight instruments to teach you how the astronauts flew the Space Shuttle in flight and in orbit. In this issue of Spacecraft Guide, we are continuing our work on the primary flight display, the electronic primary flight display, and that is pretty similar to the mechanical flight display that they had here, or the 8-ball, and we are going to be working in the primary flight display on the instrument called the pitch rate indicator. And when you click on it, you can see this is the pitch rate indicator circled in orange. Now this pitch rate indicator, what it does is just like the roll rate indicator, it provides a continuous readout of the vehicle body rotational rates. But this is on the pitch rates and are displayed on the right side of the pointer. The center mark of the scale, right here, represents 0. The graduated marks on either side indicate positive, pitch up, or negative values. And again, that is a rate. It is not a position. Like we said before, right here, the pitch error needle, that would go to a position and say, okay, now fly 2 degrees above the horizon. But that's what this error needle will do. Now this is the rate needle, and that's telling you, okay, pitch up 1 degree per second and hold it there. So that's what we're talking about. Now, if we go into general, we're going to go into the guidance, navigation, and control, and you can see that we're operating in 2 modes, stick steering or auto. Auto is the autopilot where the ship's computer is actually flying the spacecraft, and then the manual is with the control stick. But I wanted to go a little bit down here where we were talking about the rendezvous rates and the rendezvous proximity operation. Now this is talking about the scale. Now remember, we had the coarse, the medium, and the fine. Well, this is where it is defined. You see the onboard navigation system maintains state vectors in both orbital and target vehicle. During close operation, or this is separation less than 15 miles, these 2 state vectors are very accurate to maintain accurate relative state. So anything less than 15 miles is going to be coarse. Anything from 15 miles up here to the next statement is going to be the medium. And then the rendezvous radar, range and rate, are used for separation of 15 miles to 100 feet to provide the necessary relative state vector accuracy. So that is what we're talking about in rendezvous. So when you pitch up in the fine mode, where you have where it's 0 to 1 degree, you're within 15 miles to 100 feet. If you're between close operations less than 15 miles, you're in coarse. That would be 5 degrees, for 0 to 5 degrees. And when you're greater than 15, that would be coarse, which would be 0 to 15 degrees of rate. So that is where the rate is defined. Now, for our Patreon subscribing, even our free Patreon subscribers, we're going to go into the schematic again. So when we go into this, when you're a Patreon subscriber, or paying subscriber, or free, and what are you waiting for? If it's free, all you have to do is just come with me, and when we click on schematic,